Hello everyone, welcome back. So today we're going to be talking about a very important use of the quadratic formula, which is finding the position of maxima or minima on quadratic curves. So consider we had some kind of quadratic curve. I'm going to use the example in this case of y is x squared minus x minus 6. So to establish the position of the maximum or the minimum point of a quadratic curve, we first want to establish what kind of point of inflection it is, whether it's a maximum or a minimum. So to do this, we can look at the x squared coefficient of the curve and see if that's positive or negative. So if we have a positive coefficient in front of your x squared, which in this case we do, that means we have a positive quadratic curve. And if you were to sketch that curve on a graph, you'd get some kind of U-shaped curve. And a way I like to remember this is that if you have a positive curve and you draw two dots here, then it looks a bit like a smiley face. Now, if we had a negative coefficient in front of the x squared, so maybe we had negative x squared, then we'd get a negative quadratic curve. And again, on a graph, that would now look like almost the flipped version of the positive curve. So we'd get this kind of upside down U, or again, an unhappy face in this case. So what you can see then is that if we have a positive quadratic curve, we'll always have a minimum. And if we have a negative quadratic curve, we'll always have a maximum. So we've established whether it's a maximum or a minimum point that we're looking for, but now we want to establish the exact coordinates of these points. So one way to do that perhaps might be to sketch this curve out accurately. So if we again know our curve is x squared minus x minus 6, we could go through the process of sketching this accurately on a graph. So if we set y equal to 0, that will give us our x-axis intercepts. So we can then go through our usual process of factorizing this. So we could factorize that to get x plus 2 x minus 3, because again 2 and 3 multiply to negative 6 and add to negative 1. And then we could find the roots of our equation or our intercepts which satisfy this equation. So you should be able to see that x would be minus 2 or x would be positive 3. And what that means then is that if you were to sketch this curve out, you'd get a positive quadratic, remember, going through x is minus 2 and x is positive 3 on the x-axis as your intercepts. And I drew that awfully, but if you go through the points, it should look something like that. So this is minus 2, this is 3. And to find then the position of this minimum, we could use the symmetry of a quadratic curve. So if it goes through minus 2 and 3, then the midpoint here must be 0.5. And we could then sub the x value of 0.5 into our equation to get the corresponding y value. So if you were to do that, you'd get something like y is a half squared minus a half minus 6, which would be a quarter minus a half minus 6. And a quarter minus a half would give you minus a quarter minus 6. So you should be able to see then that we get minus 25 over 4. Now, that was quite a long-winded method because we first had to find the intercepts and then we had to plug that value for the midpoint back in to our equation in y and x to get out our value for y. So there's actually a much easier way we can find the position of the minimum, and as I said at the beginning of the video, we can use completing the square to do that. So let's come back to our equation, and now let's complete the square on this equation. Now you should remember from doing completing the square that this part, x squared minus x, can be rewritten as x minus a half all squared minus a quarter, and then we can take down our minus 6 here, so we could do x minus a half all squared minus a quarter minus 6. And then we can simplify this a little bit further to get x minus a quarter all squared, and then minus 25 over 4. And you should be able to see there that's the same number we had up here. So what does this tell us about the graph then? Well, again, we know we have some kind of positive curve, but we don't yet know what this position of the minimum is going to be. But we could look at our completed the square form of our equation and use that to find where the minimum would occur. So if we consider this first part of our completed the square form, we have something inside of some brackets squared. So for any number squared, the minimum value it can take always has to be greater than 1, because we can't square something and get out a negative number. So the minimum of this thing in brackets here then would have to be 0. And you can see that already would give us our value for our x-coordinate. Because in order for this entire bracket squared to equal 0, the thing inside the brackets would have to equal 0. And so x, you should be able to see, would have to equal a half to cancel with this negative a half here. And now if that entire bracket is 0 then the only thing we have left is this constant minus 25 over 4. So you should be able to see that y then is minus 25 over 4. And so our overall coordinates for the minimum, or I'll put it down here, would be a half minus 25 over 4. So let's repeat that, but for a different example then, but just using completing the square. So let's say now we had a different example, maybe y is negative x squared plus 2x plus 1. So if we complete the square on this is a bit of a more tricky example because we have this negative sign, but to start off with we might want to take the negative sign out completely, so we'd get minus x squared minus 2x minus 1. And so if we do our completing the square, this x squared minus 2x, if we complete the square on that, we get x minus 1 all squared minus 1. And then adding in this other negative 1 on the end, then we get another negative 1. And so then we have minus x minus 1 all squared. These two negative 1s would combine to negative 2, but then if we multiply them by that negative sign at the front, we'd get positive 2. So now we have completed the square form of this equation, and we can use this now then to work out the position of the maxima or the minima. So now we have a negative coefficient in front of our x squared, so we know for sure that this curve is going to look like some kind of upside down U, but we don't yet know the position of what the maximum is going to be. So in order for y to be as big as possible, you should be able to see that we want this bracket here to be as small as possible. And that's because we have this negative sign in front of the bracket. So any large number inside that bracket would create a very large negative value of y. So what we want then, again, is for that bracket to equal 0. So we can say then that x minus 1 would have to equal 0, or x would have to equal 1. And if that whole bracket equals 0, then y must equal 2. So now our coordinates for this point, you should be able to see, are 1, 2. So I hope that was useful and gave you perhaps a quicker way of finding the position of maxima and minima of quadratic curves. This isn't actually the only method of finding that. We'll come on to other methods in later videos, but it's still very much something you could be asked to do in an exam.